We're just very fortunate to have our next speaker here with us today. But before I introduce our next speaker, I just want to say one thing. We actually have been looking into who traveled the furthest to come to this conference. We had people from the UK, from Germany, from Ireland, from Japan. And I think the one that won the award for being the furthest away, coming all the way to Washington, D.C., is a team from Japan. So they flew the furthest in coming to Washington here. And now it's my privilege to actually introduce, an honor to introduce a colleague from the Office of Science and Technology Policy at the White House, Dr. Sally Benson. Sally is a Deputy Director for Energy and Chief Strategist for Energy Transition at the White House Office of Science and Technology Policy. And internationally recognized energy expert, Sally was trained as an earth scientist and engineer prior to her role at the White House. Sally worked at the Stanford University before moving to the White House, and she was a Precourt Family Professor of Energy Resources Engineering in the School of Earth, Energy, and Environment Sciences. During her time at Stanford, she was also the director of the Global Climate and Energy Project, a research program focused on discovering and developing new technologies for reducing carbon dioxide emission from the energy systems. Sally also has held many positions at Lawrence Berkeley National Lab. She has been coordinating lead author for the Intergovernmental Panel on Climate Change and is a member of several National Academies of Sciences studies related to energy and environment. There's a lot more that I can tell you about Dr. Sally Benson, but I'll turn the podium over to her, and thank you very much, Sally, for being with us here today.
Anyway, thank you, Nabil, very, very much. Now I'm going to try this. It's so great to be here. This is a community that is new to me in many ways, so and I really admire the foresight for those of you who've been involved in this for so long. And then for those newcomers, I congratulate you on having the really good judgment to realize how important this is for the future of our planet and all of us who live here. So I'm going to be talking about the intersection between our net zero game changers work and circular economy. And basically the idea is thinking about how do we make the case about the benefits of circular economy for solving the climate problem. I will say that our work so far is very qualitative. And it's going to be, I think, really important as we move forward to think about how we can take the ideas here and the ideas in the climate solutions community and to start to really quantify those benefits so that we can even make a stronger case of how important this is. Okay, so now I'm going to switch and really talk about climate and the commitments that have been made by this president, or the goals to get to net zero emissions by 2050 with 50 to 52% reductions in greenhouse gas emissions by 2030 and a net zero electricity system as soon as 2035. Okay, so these are incredibly ambitious goals. This graph shows some work from the long-term strategy of the United States. This was a document that was jointly prepared between the State Department and the Climate Policy Office in the White House. And as you can see that, yes, indeed, the U.S. emissions have dropped 17% below the 2005 levels. But we have a long way to go and a very, very steep decline in emissions, basically sort of accelerating, 3- to 4-fold the historic rate of emissions reductions to get to this target. So the question then is, what will it take to achieve this? And so the tools that people use are basically very complicated techno-economic models, such as GCAM. There are many others, both in the academic as well as in the public sector. And here's an example of a set of runs that underpin the long-term strategy. And we can look across all of our existing emissions and look at trajectories to zero. So if you look at the one that's sort of in orange color, that's transportation. Okay, so that you can see that there's a range of values, but basically getting close to zero. So what will that take? Okay, electrification, batteries, powertrains, fundamentally changing the way that we transport people today. We also might use some hydrogen. Biofuels will probably also be very important for things like aviation, to create sustainable aviation fuels. And then for long-haul, heavy-duty shipping, perhaps we might even be thinking about things like micro-reactors or small modular reactors that could create zero-emission shipping. Okay, next, if we look at the list, we've got buildings, that's in yellow. That's less emissions than transportation, for example, starting out, but quite difficult to decarbonize. We've got, a huge existing stock of buildings with embedded systems. So what will it take to reduce emissions there? Well, again, electrification, really key strategy. Heat pumps. You hear a lot about heat pumps in the newspapers these days. That's great. But geothermal is also another very interesting option, particularly for district heating systems. And then there might be some times when hydrogen could also be a solution for buildings. If we look to industry, that is the greenish line. Okay, well, what can we do there? Well, we can take existing processes and use sort of an end-of-pipe solution of carbon capture and storage for things like steel, cement, ammonia, and chemicals. We can also use hydrogen as a substitute fuel. And we might also think about doing processes differently, using, for example, electrochemical processes as opposed to combustion. And then finally, really I think the subject, a lot of the discussion here is an entirely new manufacturing processes and new chemistries underpinning a new industrial revolution. And then finally, we can look at the electricity sector. Obviously, renewables will play a very big part, very, very massive scale of energy storage, as well as things like nuclear energy, fission and fusion, and then particularly in the transition, also carbon capture and storage on fossil fuel plants that are needed to provide reliability to the grid. Okay, so if you look at the list on the right and you look at how we do everything today, which is largely reliant on combustion, basically we're talking about everything being fundamentally different. And if we look at what will it take, we're talking about just for electrification. That's just one sliver of this. We're talking about 1 billion new devices to do this. So that can be looked at as a big challenge, but it can also be looked at as a massive opportunity, I think particularly for this community, because we can think we're going to start building 1 billion devices and let's do it differently. Let's not do things the way we've been doing them. And as we embark on this amazing and deep transition, we also realize that it's going to require success from multiple perspectives. We can't just put on our blinders and look at greenhouse gas emissions. We also have to look at how can we sustain and create good-paying jobs, and how can we address historical inequities, and how come we can restore and clean up past pollutions, as we've heard about the importance of regenerative component to circularity. And how can we as we go through all this, how do we ensure energy security and increase global competitiveness? This is a global economy, and it's really important to build on the strengths of your workforce to create opportunities. And then finally, how can we do this in a way that maintains or improves geopolitical stability? So that's a tall order, right? So lots of things to think about. But again, if you think about circularity, it underpins many of these objectives as well. So I hope by now that you're persuaded, like I am, that we're at the very beginning of a once-in-a-century energy and industrial transformation, and that we have to do it differently. We need to work with nature as opposed to against it. We need to increase material and energy efficiency, as we've heard, by design. And we need to provide jobs that are good for both people and the environment. And underpinning all of this needs to be a foundation of clean and abundant energy, particularly electricity. And in this next revolution, this next industrial revolution, digitized, optimized, and smart. So we're going to need a lot more electronic devices and so forth to be able to optimize the system in real time. And then finally, underpinning this is how can we use this transformation to increase national water, energy, and food security. So this is the work that a team of us across the government have been engaged in. 17 different agencies have been involved. Many of the ones that you've already heard about today, so I will for a moment leave off all of those and get back to that again in the beginning. So to start off this work, this team came together, looked at this whole set of emissions, across 100% of those emissions, and came up with a set of 37 different game-changing technologies that, taken together, would provide a high degree of assurance that we could achieve our goals if they were available soon enough. So there were technologies that focused on a particular sector of the energy system, so transportation technology, electricity generation, industrial processes, buildings and infrastructure, agriculture and methane reduction, and then finally carbon removal, another very important part of being able to achieve our goals. So those focused on a particular sector, but in addition to this, what we found as we were going through the analysis, that there were some technologies that actually were necessary and helpful across the entire board. So we call this cross-cutting innovation. So that includes things like how do you build a zero-emission bulk electricity system, and how do you develop long-duration storage, and how do you create a distribution system for getting electricity when and where it's needed to customers that's smart, and how can we reuse our existing infrastructure and rights of way so that we can get there faster. And then biofuels, alternative and efficient biofuels, as well as the idea that could we actually make carbon neutral fuels by capturing carbon dioxide from the air, taking clean electricity and converting that to fuels that we could use either directly or for long-term storage. And then hydrogen, of course, is a key component of that. In addition, carbon capture and storage, but the one that we're focused on here, again, is circular economy and secure supply chains, recognized as a very, very important cross-cutting technology that was going to help meet our goals. So that was a really long list, right? 37 technologies. You know, what do you do when you have 37? Any list that's that long is sort of not terribly useful. So we decided that we needed to take a look at this and prioritize what we needed to get to work on first. And we went through a careful exercise where we looked at a whole set of criteria across climate and environment, justice and equity, economy, security and reliability. And I'm not going to read all the details under there, but we actually took a hard look and tried to quantify, at least to the best of our ability, what would be the benefits of all of these technologies. And here's where I come back to, it would be fantastic had there been models, techno-economic models of the economy that included things like circularity that would help us really quantify those benefits. So for all of those you who are interested in systems and are interested in modeling projects, that one would have great, great value. So we relied on primarily qualitative assessment for many of these. But when we looked at circular economy, we identified a number of key areas where there were huge benefits, and these, I know you know all of these because this is what you think about day in and day out. But starting with stronger supply chains, if we think about batteries today, which are scaling massively, to the extent that we can take all of these automotive batteries, which are starting to come out of their first life cycle, and recapture the benefits of all of that lithium and copper and graphite and cobalt and nickel and so forth. We've got to do that, and that will help strengthen domestic and reliable supply chains. Obviously, there's an opportunity for more jobs as we create these whole new businesses of basically repurposing and remanufacturing and ultimately recycling. We can also reduce greenhouse gas intensity if we can bypass having to start everything through that extractive cycle all the way through to ending up in a landfill. And if we do this right, we can have cleaner air and water, our food systems can be more secure, and gradually over time, we can reduce the extractive requirements to meet the human consumption's needs. And this is really important right now because we're just starting to ramp up mining all across all those elements of a battery that I just talked about. There's a global explosion in the extraction of those materials to the extent that we can actually anticipate and design the system to reincorporate products coming out of their useful life. That will help us set the bar on how much of this extractive processes do we need as we undergo this massive transformation that we've started now. So based on all of this, and I think one of the main reasons I'm here today is that we identified 5 priorities, and one of them included circularity as a key component. But I'll go through the whole list in case you're curious. So the first one is net zero power grid and electrification. About 50% of global emissions reductions are anticipated to be associated with these 2 combined actions of clean electricity as well as electrification of transportation, particularly light duty, as well as buildings. And we talked about in the U.S. to accomplish that, again, 1 billion new devices, so you also get a sense of the scale of what it will take to achieve that. Second one is in the area of low greenhouse gas building, heating, and cooling, or basically low greenhouse gas space conditioning. And this will include a new class of refrigerants or refrigerant-free cooling with low global warming potential. And next we have net zero aviation. So that will include both things like sustainable aviation fuels, as well as, can we fly airport, short hop flights on batteries, so electrify them, or could we use hydrogen as part of our transportation strategy? Next one is alternative pathways and circular economy for industrial processes and fuel synthesis. I mentioned that there's a big segment of the economy, 25% of our emissions, that today largely rely on combustion. How are we going to transform this? And herein is a huge opportunity for switching to a new generation of inherently cleaner processing, including circularity. And then finally, fusion energy at scale, cost competitive with conventional energy. All you need to do is read the papers today to realize that there's a very exciting developments. This is not imminent. This is a very, very hard technical challenge, but I think that we can see within a time that will make a significant impact on global decarbonization that fusion energy will be another clean energy option. So looking at a little bit more closely at industrial products and fuels for net zero circular economy. So we'll be focusing on low carbon steel, aluminum, cement, chemicals, industrial heat, clean water, and electrofuels. So this is a big, broad bucket of technologies. So we're not so interested in how to solve each one of these individually, but looking across them and identifying, are there fundamentally new industrial processes that could be used to manufacture these fundamental building blocks of our economy. And I'm going to skip here. So what do we need innovation for? So obviously innovative chemistries, industrial processes, and devices that are inherently circular. And we also need to, of course, design, but manufacture, operate, and monitor the materials throughout their life cycle. So we've heard about exciting ideas like material passports, but we also need to think about the operational phases of these devices, which actually have a very big impact on their potential second life use, batteries in particular. You can operate them in the way at the end that they have a long life after you repurpose them from transport, or they may fail very quickly. And we need to keep that information embedded with that battery so people can figure out actually how it is that you assess the remaining useful life. And we need to think about, at the end of the day, it's people that we're providing services for, so how can we do this at a lower cost with reuse, repair, recycling in mind? And of course, a very important part of this, which we've heard about already, is setting standards, increasing transparency, tracking material stocks and flows, and assessing full life cycle impacts of these technologies. And finally, we need business models and policies that put a value on the benefits of circularity. If we can't start getting credit for that, it's going to create a higher hill for these technologies to enter the marketplace. So just in wrapping up, well, I'm going to stop here. Okay. Anyway, thank you so much. I want to say congratulations to Dr. Nasser, who's you know who he is. Anyway, everyone knows who he is. Anyway, so congratulations. It's so exciting to see the room full of people. Also, the Ellen MacArthur Foundation, leaders for decades and partners in a wonderful event that we did a couple of weeks ago. So thank you for their leadership. Of course, the Department of Energy and the Office of Advanced Materials and Manufacturing Technology have been leading the way in this, and many colleagues across the federal agency. It's been really rewarding to work with many of you who I am sure who are here. I am inspired by your persistence and dedication, and I think there's big opportunity to move forward. And, I'll leave just with one word, or actually one sentence. So circularity is a strategy. I've learned that. It's not an idea anymore. It's a strategy whose time has come, and it's about time. So thank you very much.